I'm Lewis, and that's Sam, and our project is on vectors and how to use them. Vectors are anything that contain a direction and a magnitude. This arrow, for example. Direction is in the head of the arrow, and the magnitude is the length of the arrow. Another example of a vector is a pen, throwing it. Direction, magnitude. Or my phone. Direction, magnitude. Or this ruler. Direction and magnitude. Vectors apply to many subjects in math. An example of this is physics or geometry, where they apply to the shapes and the throwing or direction is very easy to explain. I'm pointing that way, the direction is that way. That way, that way, pretty easy. But magnitude is the number of units in the vector. So example, 10 centimeters. 10 is the magnitude of the unit, 10 centimeters. Or 50 seconds. Seconds is the unit, and 50 is the magnitude. All vectors need a magnitude, or else they are not considered vectors.
Now we're going to talk about what aren't vectors. So remember that a vector has to have magnitude and direction. So here, this has a direction, but it has no magnitude. However, here, it has a magnitude, but it's lacking a direction. And here, this doesn't have a magnitude or direction. Now I'm going to teach you guys how to add vectors. Let's say I have one vector, 90-degree vector, with a magnitude of 10. And let's say I have another vector, a 45-degree vector, with a magnitude of 5. To add these, I put the magnitude of the vector with the magnitude of 5 on top of the one magnitude of 10. And get this final destination. Another way I could represent this was with one vector going from the start to this final destination. They may look different, but they have the same result. Now to my colleague.
And now we're going to explain vectors, or adding vectors, on the soccer field. So here we have the goalie and a ball. Now the goal of soccer is to score in the goal, but sometimes you have to pass it around the back or dribble out wide to get there. So say you have to dribble or pass it out wide at a 45-degree angle, 20 feet. Next, you have to dribble down line 10 feet. And finally, cross it in the box 12 feet. Now, like adding vectors, you could just go down 10 and cross it in 12. And you would end up at this destination, which is very close to the goalie. Another way you could display this is just drawing one vector all the way to the final destination. And even though it doesn't cover the same ground you did, it has the same final product, which means it represents the same thing.
So now we're going to talk about subtracting vectors. So here we have a vector u going up that way, a vector v going down that way. So to subtract them, we do what we normally do when adding. So we put the tail of vector v on the head of vector u. But now we will reflect it over there. So it's here. And this is the product of subtracting vector u from vector v.
The reason we chose this topic is because vectors was the most interesting topic out of the three we had to research. Also, they applied to many different forms of math, such as physics or geometry.
Yeah, I learned a lot about vectors during this unit. Before this unit, I had no idea what vectors were. But now I know what context to use them in, how to use them, and what a vector is.